let's see if we can make a game with Pygame. I've never used this before, so bear with me. Let's make our first game. Here we go. Here we go. Okay, so pip install. Do I have Python installed? Python, yes. Version 3.12. Okay. Pip install. Let's use a Python environment variable. Environment variable. Python virtual environment. Why do we want to set up a virtual environment? We want to do this because we don't want to install a bunch of stuff on our computer directly. What we want to do is we want to have the virtual environment with everything contained, everything that we install, so that when you're working on a different Python project, you don't have all the same stuff installed. Because if I'm working on a Python project that's bringing in a bunch of numbers and trying to predict which stock is going to take off and make me millions and millions of dollars, I probably don't need Pygame installed. So we can use these virtual environments, VENV, to do that. So the way it works is this: Python -m VENV venv, and then we give it the location of the virtual environment. We're just going to call it env, and it'll be a directory in our game directory here. Waiting for that to happen. It's done. Okay, so now we have this env folder here, and inside there are the scripts libraries include. So scripts, see, we've got pip, we've got Python, we've got pip3, and then we have this activate here. So I'm on PowerShell right now, so I'm going to use this PS1, this activate PS1 here. Depending on your system, it might be different. If you're on Linux, I think you just use activate. If you're in the command prompt, use the batch file. If you're in PowerShell, use this. So let's go env script activate. Nice. Okay, so see this env over here? This means we're in our environment, and everything that we pip install is going to be just for this environment. It's not going to be for anything else. So that's that part done. Documentation here, official Python docs if you want more info. Python, Pygame. So pip install, what do we have here? Python version. Okay, so that's the same. And then Python 3 version, not found. Okay, so we just use Python. Again, your machine might be different. Python 3, Python, just check that you are using version 3 of something, because version 2 is different. So let's install this. Except we are using, oh, no. Where did it go? Okay. Let's install this. So Python -m pip install u pygame user. Okay. Straight from the Pygame documentation. No such option user. Oh, it's just user. I thought user sounded weird. There we go. Okay, that looks better. New version of pip available. Worry about that later. Oh no, cannot perform a user install. Oh, side packages are not visible in this virtual environment. Okay, fine. Let's do it without it. And now we wait. So that was quick, nice. So Pygame is installed. If we do, let's just do this. Pygame.examples.aliens. I mean, this is straight out of the documentation. So, and again, Python, change it to your whatever your Python is. Okay, let's see what this aliens thing is. Whoa! Oh my god. Whoa. Died already. Okay, that was fun. Let's see if we can make our own. So, let's see. What do we have here? Let's go straight into the docs. Quick start. Okay, this looks. Okay, it looks fine. So, um, welcome to Pygame. Once you've got Pygame installed, we do. The next question is how to get a game loop running. Yes, that was my question. Pygame, unlike some other libraries, gives you full control. Oh, unlike some other libraries, getting a bit snarky in the old documentation here, gives you full control of program execution. That freedom means it's easy to mess up your initial steps, okay? Here's a good example of a basic setup. Opens the window, updates the screen, and handles events. Okay, here's an example showing the basic game loop. Let's grab all of that. And then, then we can go through it step by step to make sure we understand it. Okay, one thing you should never do is just blindly copy and run code off the internet. That is a bad idea. So that's what we're going to do, but we're going to go through it line by line and make sure that we understand it. So where are we? Let's just call it mygame.py. Whoops, oops. I don't know what that was. Fail to source defaults.vim. Okay, I've got a problem with my Vim setup. I don't know why. But let's get started with Pygame. Okay, so um, yes, here our super awesome game. Import Pygame. Okay, imports the Pygame library. Pygame setup. Pygame init. Okay, initialize Pygame. Screen Pygame display set mode 1280 by 720. Okay, so looks like we're setting the display size. Clock, Pygame time clock. That's interesting. Let's go back to that at some point and see what that means. Okay, let's do it now. Where are the docs? I'm going to open this up in a new window. Okay. Oh, Pygame init. So we can go through that as well because that is the first thing that we're doing here. So initialize all imported Pygame modules. Initialize all imported Pygame modules. No exceptions. No exceptions will be raised if a module fails. But the total number, if successful and failed inits, will be returned as a tuple. Okay. You can always initialize individual modules manually, but Pygame init is a convenient way to get everything started. The init function for individual modules will raise exceptions when they fail. Okay, so this is the fastest way to get everything started. The convenient way to get everything started. So let's do that. Okay, Pygame display. I think this one's pretty obvious what it's doing. So we're setting the resolution here. I'm sure there's a whole bunch more options here that we can set. So let's go back to that later. No, let's do it now. Display. There it is. So display init, but this is being initialized by the other one, so we don't have to worry about it. Then set mode is what we're looking for. Initialize a window or screen for display. So yeah, exactly what we guessed. So size is the size of it. Flags depth display vsync, and it returns a surface. We'll create a display surface. Okay, that's interesting. I guess we can look at what the display surface is at another time. But there's some nice constants here for us that we can use if we want. Okay, let's stick with the basics for now, and we'll continue to initialize with the size 1280 by 720. Okay, what is this clock? Time, 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 time. There it is. Okay, and clock. Here we go. Create an object to help track time. TikTok. Okay, so tick updates the clock. Right. So, okay. So we create a clock and we store it here. Interested to see what we do with that later. So, let's keep that one in mind. Running true. Okay. While running, okay. So, yep. Here's our game loop. So this is an infinite loop um, until something stops running. So this running variable, if we change that to false, then this will stop being true, and we'll get to this quit here. So, okay, poll for events. Okay, pygame.quit event means the user clicked the X to close your window. Okay, for event in Pygame. Okay, yeah. So we're looping through all of the events. Let's take a look at events. Oh, pump up the events. For event in Pygame event get. Where is get? Okay. Okay, so get events from the queue, and it will return an event list. This will get all the messages and remove them from the queue. Okay, good to know. Remove them from the queue. If a type or sequence of types is given, only those messages will be removed from the queue and returned. If a type or sequence of types is passed in the exclude, sorry. If a type or sequence of types is passed in the exclude argument instead, then only other messages will be removed from the queue. If an exclude parameter is passed, the event type parameter must be none. Okay. Cool. Okay. So we get a bunch of events from the queue. It looks like one of these events, and the type of that event, it could be a quit type. So it looks like this is one of those, again, one of these constants. It's part of Pygame. So if someone hits the X on our window, this event gets chucked in the queue. And then here we loop through all those events. We look for that one and we go, whoa, someone wants to quit. And then we change running to false. So we go out here and Pygame quit. Okay. So fill the screen with a color to wipe away anything from the last frame. So screen fill purple. Looks like we're going to fill the screen with purple. Render your game here. Flip the display to put your work on screen. Display flip. So what on earth is flip? What the flip is flip? Display flip. Okay, update the full display surface to the screen. This will update the contents of the entire display. If your display mode is using the flags Pygame HW surface and Pygame double buff on Pygame 1, this will wait for a vertical retrace and swap the surfaces. Okay. When using Pygame OpenGL, this mode will perform a GL buffer swap. Not gonna lie, I don't know what any of that means, so maybe we can do some research later on, but I think we should get started with the very basics first. Let's just stick with filling the screen purple and seeing what happens. Clock tick 60, so limit FPS to 60. Okay, that's interesting. Tick, so okay, tick. Clock tick. We looked at clock tick before. Okay, where are we? Clock tick. Okay, clock tick. So we did look at it before. Update the clock. This method should be called once per frame. Oh, okay. So yeah, okay. Okay. So you pass the frame rate in there. Okay, okay. So yeah, I was wondering, like, okay, we update the clock, but we give it 60. What does that got to do with the FPS? But okay, so that's what we're doing in there. We're telling it to that's the frame rate. So if you pass the optional frame rate argument to the function, if you if you pass the optional frame rate argument to the function, what? Sorry, there's no two in there. I just can't read. If you pass the optional frame rate argument, there should be a comma in there though. The function will delay to keep the game running slower than the given ticks per second. This is a combination of I can't read and also this is a very long, confusing sentence. There should be a comma in there somewhere. This can be used to help limit the runtime speed of a game. By calling clock tick 40 once per frame, the program will never run at more than 40 frames per second. Okay, so that's what we're doing, except with 60 frames per second. Okay, I'm excited to see this purple fill screen thing. So let's do it. Oh no, I didn't want to do that. Um, uh, okay, yep, all right. Good. Okay. Let's just run it. Python my game.py. Oh, there it is. I'm colorblind, but this must be purple. Um, great. Good. Okay. There we go. Success. And it looks like the quit runs as well. Hello from the Pygame community. Well, thank you. I feel very welcomed in the community. Maybe look at that. We can contribute to Pygame. Maybe once when I know how to do more than just create a purple window, I'll be able to contribute more, but not yet. Okay, so great. Oh, okay. This one's exciting. Now we can show a circle and move it around. Um, so what is different here? So we're still importing Pygame, we're still initializing it. Screen is still the same size. We're still setting up the clock, it's still running, but DT is a new one. I wonder what DT stands for. Let's go into our game. DT, okay. I mean, let's add it. Let's add it. DT equals 0. And player pos, this has got to be player position. So Pygame vector 2. Screen get width divided by 2, screen get height divided by 2. Okay, so vector 2, I think this is a 2D vector. So you've got, is this worth bringing up paint to do it? I don't know. Probably not. Do I need to explain what a 2D vector is? Let's do it anyway. So we've got, I probably don't even know how to use Notepad. Paint, MS Paint. Okay, so 2D vector, you've got your 2D space here with the X and Y coordinates, and what I'm guessing is we have two. Either these are integers or floats, but we have two vectors here that says, 5 by 5, and then say this is like 10. Oh, this is horrible. Sorry. This might not even be worth it. Um, okay, 1 to 10, 1 to 10, and then 5 and 5. So say our vector is 5 and 5, then that's gonna be here, right? Because you got 5 this way and 5 this way. This is the worst explanation of a 2D vector ever, but we did it, so good for us. Player position. So it looks like we're setting the player position. Now, given that we're getting the screen width and the screen height and dividing it by 2, it looks like we're trying to smack this slap bang in the middle of the screen. So that's where we're going to put our player to start with. So let's just copy and paste that in. Do we need to check what this vector2 thing is? No, I'm pretty sure it's just two integers or floats. I mean, it would be good to know if it is an integer or a float, but there we are. So again, we check to see if the user wants to quit. Otherwise, we fill the screen with purple. Okay, so now we have an interesting new function here, draw circle. So let's go through it first and see what's happening here. So Pygame, draw circle, and then we pass in screen, which is our display that we've created here. Red, that must be the color. Just a guess, but I'm guessing it's the color. Player position, which is probably this vector here that we've created, slap bang in the middle of the screen, and then 40. I'm guessing this will be, given it's a circle, maybe it's the radius or the diameter of the circle. You know what? Let's go to the documentation and see which it is. Draw, there it is, draw, circle, circle. Okay, parameters. So, radius, right, good. So, surface color center. Yes. Okay. So, yeah, that's a good point. So, player position is the exact center of the circle. Good to know. And then radius. So um, yes, the radius. Do I need to explain what a radius is? Probably not. Okay. Radius is half of the way to the middle of the circle. That's probably a terrible explanation. Anyway. Um, returns a rect. A circle returns a rectangle. Is that correct? Returns a rect bounding the changed pixels. If nothing is drawn, bounding the rect's position. Position will be center. Okay. Is it really a rectangle? The circle returns a rectangle. How about that? Okay, anyway, let's just draw a red circle in the middle of the screen. Where did we do that? I think we did that after the fill screen purple. Did we do it in render your game here? No, it looks like that whole comment has been removed, which I'm cool with. I was not overly attached to it. Okay, so draw a red circle. Okay, now it looks like we check for some keys here to see if the keys are pressed, and then I think maybe we move it around. But I can't wait. The excitement and anticipation is killing me. I want to see this red circle. So I'm going to run it the way it is now, and then we'll handle the key stuff later. Python, my game. Oh, there it is. Oh, my eyes. Oh, my eyes are burning. Oh, that is horrible. That is horrible. Okay, but I mean, it's doing what we're expecting, right? We've got a circle right in the middle of the screen. I'm guessing that is 40 pixels of the radius. There we go. That's the radius, everyone. Okay. My eyes. My eyes. Let's change this. We don't have to stick with the documentation. We can change this. Okay. What colors should we go with? At the risk of being really boring, I'm gonna make it a white screen with a red ball. Look at that, it's Japan. Okay. Is that the Japanese flag? Japanese flag. Yeah. Yeah. If we make the circle bigger, then we've got the Japanese flag. Okay. Keys. Let's look at this. So get the keys from Pygame key pressed. I kind of want to see the documentation on this. Keys, key. Get pressed? Is that what we had? Yeah, key get pressed. Get pressed key. Okay, get the state of all keyboard buttons. And return some balls. Sorry. Returns a sequence of Boolean values representing the state of every key on the keyboard. Use the key constant values to index the array. A true value means that the button is pressed. Okay, good. So we're grabbing all those keys and then we're checking for specific indexes to see if they're pressed. So WSAD. Great. Look, it's weird that it's like K underscore W. I'm guessing that means keyboard or key. All right. I'm just going to copy and paste this whole thing in because I don't want to type it all out. All right. Where do we put it? After the circle is drawn. Okay. Let's paste it in there. Okay, so I mean this next thing here. Okay, so let's look at this. So player pos is this variable we created. It's where we're defining at the start. It's smack bang in the middle of the screen, and that's where we're putting the center of the circle that we're creating. Now, when each of these keys are pressed, we're altering that variable, and we're altering the x and y parameters of it, remembering that this is a vector too. So a vector has an x and a y coordinate, and the x and y is being altered depending on what key we're pressing. So here we're pressing the W key, which for any gamers out there, you would know that the W key is the upward direction. So what we're doing is we're interestingly removing or lessening the player position by 300 pixels. So interesting is the W, which is the up key, and yet the Y is going down in value. That must be to do with the coordinate system of Pygame. We can look into that later, but I guess that's just an interesting one to keep in mind. So then the S, again, gamers would know, S is the down sort of thing, WSAD on the keyboard. So S is the down one, but again, we're increasing the Y coordinate by 300 pixels. So we're timesing it here by dt. Now I'm starting to guess that dt means delta time, the change in time. But let's wait until we get to a line that actually gives us some more on that, because then we can go into it there. So again, A and D, A is the left, D is the right movement, and then the same, but instead of the Y coordinate, it's the X coordinate that is being moved. So okay, keys is doing that. Okay, Pygame flip, and then right, yes. Okay, so here we're updating delta time. So dt is delta time in seconds since last frame, used for frame rate independent physics. So the delta time is the clock tick limited to 60 frames per second divided by 1,000. Can I explain delta time in gaming? Do I know it well enough? Sorry, in game development. Do I know it well enough? I don't know. I'll give it a go. This could be wrong, so maybe we'll talk about it later. But this is what I think it is. So you've got a computer, right? And a computer acts on instructions. That's what your CPU does. It just does everything that it's told to do by computer programs. Do this, then do this, then do this, then do this. But if you tell um, one person's computer to do this, then this, then this, then this, and then someone else is on another computer, you can't guarantee that it's going to be the same speed, because one person might have a really, really new fast CPU. One person might have a CPU back from the 90s that's much, much slower. So what we need to do is we need to find a way of of making I mean here independent physics. So we need to make things move at a predictable speed independent of what speed your CPU is. So the screen is going to only update um, the screen's only going to update at 60 frames per second here. That's what we're limiting it to. Um, um, but the delta time, uh, as it says here, is the time in seconds since the last frame. So the CPU is gonna change the frame, change to the next frame, and the time that it takes to do that could be different for different computers. So like I was saying, slower computer from the 90s is going to take longer. Newer computer from today is going to be super fast. So we try to adjust for that by having a delta time, and here we're setting the delta time as the uh, our our clock here. Um, the delta, yeah, I'll just read exactly what it says. Limit the frames per second to 60. The delta time is the number of seconds since the last frame. So here we're dividing it by 1,000. I'm guessing this is how we're getting the seconds. Sorry, that's a terrible explanation, but I did warn you that I didn't really know it well enough to explain it. Maybe we'll go into it again later if it's even worth it. I mean, or maybe we can take away the delta time and you can see just how janky it's going to be on different CPUs. But let's leave it in there for now. Okay, so we need that. Um, so this one, um, yeah, this one we're replacing. I mean, we're still doing the same thing. We're still limiting to 60 FPS, but we're just saving it to this delta time variable. Okay, now that's enough. Let's run this thing. So Python my game. Okay, here we are back on the flag of Japan. I'm going to move the WSAD keys and let's see it move around. So I'm pushing the W key and we go up. Nice. Oh, we just keep on going. There's no boundaries at all. S, we're going down. D, we're going to the right. And A, we're going to the left. So I can move around. Now, this is not perfect. There are problems here. Obviously, the boundary is one problem. Another problem is the diagonal is much faster than the left and right. So you go left, it goes that speed, but if you're going diagonal, you go much faster. So yeah, we're going to address that later. But isn't this cool? We can move a red circle around the white screen. So this is good. We already have movement. We already have action, and now all we need to do is just build an exciting game. Yeah. Okay. That is the quick start for Pygame. So join me in the next episode to start building something of our own creation. What that is yet, I don't know. I'll dream up some ideas. If you have some ideas, leave them in the comments. I would love to build a game together. That would be fun. Okay. Thank you. See you next time.